Now we get to surface. Surface feature of the Earth is one of the most interesting because it has something known as plate tectonics. No other planet has that. Of course, it has us, which makes it the most important planet, right? Alfred Wegener was a German scientist who popularized this concept. When he first mentioned it, it was not accepted that well. He said that we live on a bunch of plates, and the plates are jostling and moving past each other, and he called this theory continental drift. He said the continents keep drifting past each other. So we live on a bunch of plates which constantly are in motion. The original continent that used to exist, he called Pangaea, okay? And this one split into two continents called Gondwanaland and Laurasia. You see here, this is the 237 million years ago, the supercontinent called Pangaea. See here, Pangaea? This is what it looked like. Gondwanaland, then started splitting. Australia and Antarctica were together. Then most of the Earth was oceans. And then you got here South America, Africa, Arabia. They're all connected, pretty much, you know. And then you got North America, Europe. Now Europe is beginning to split. Siberia, North China. And then 152 million years ago, some of the split has already begun happening. North America is splitting. Siberia, Africa, Antarctica, and as Africa are still connected. South Africa and South America and Africa are connected. Why? Because we've studied the fossils of the animals that are in the eastern and western region of Africa, you see. We know that they are very similar here. And then finally they split, and you get this guy splits, and then this guy, and then they look different. You could also go to websites and say, what will the Earth look like in the future? And then there's maps of that, okay? You will be surprised because you can do a computer model and you can estimate what it's gonna look like 100 million years later in the future. It might scare you, you know. 140 million years ago. See, interesting here, they start together. This is India, it's an island. Australia was connected and then it separated, and India got pushed into China, it got pushed into Asia. Amazing. That's how, when India pushed into Asia, that's how you form the mountains, okay? The tallest mountains in the world, right? Mount Everest. Okay, the major plates in the world. This is kind of close to our heart because we live in LA, and earthquake, the presence of an earthquake is ever present in our lives. We know that there's going to be an earthquake. Why? Because we live near a plate. If any topic should interest you in this chapter, it is the topic of plates. You cannot escape it. Where do you live in America? You live here. And the western border of the, you live in the western border of the Pacific plate. You see, this is a huge plate here. So we live here in LA. And the rest of America, they don't really care about earthquakes as much because they live in the middle of North American plate. They don't care. They have other natural disasters to deal with. Hurricanes, tornadoes, floods, and whatever. But our natural disaster, earthquake. It's going to happen. You can't avoid it because this plate is passing each other. It's a transform boundary, okay? Little by little, that's going to happen. It's going to, okay? Eventually, LA will go up, up, up. San Francisco is going to come down, down, down. Millions of years later, LA and San Francisco right next to each other, okay? And California will split into two. The major plates are Pacific plate, that's huge plate, this one. North and South American plate. The North American plate is this one. South American plate is this one. Eurasian plate, that's this one. Huge, huge one, Eurasian plate is this one. This is another picture of that, you see. North American plate, South American, Nazca, Pacific plate. You see here, California. It's kind of hard to see, but we're living over here on the western side of the West Pacific plate, and then these two plates are passing each other. If you live here or here, you don't worry too much about earthquakes. You're in the middle of a plate. If you live here, you don't worry about earthquakes. But if you live here, you see, Spain, Italy, Turkey, Iran, Syria, over here, Africa, anywhere near plates, that's where it's dangerous. Lot of earthquake activity, you see. Okay, there's three kinds of boundaries along plates. One is divergent boundary. The plates are moving apart from each other, okay? Going like that, diverging away from each other. Where is, these are called rift valleys. And the main place, one of the main places that this happens is this one here. You see here? The mid-Atlantic ridge. This is a divergent boundary. See, they're separating from each other. It's happening underneath the ocean. You see here? It's coming. The new material, remember I told you about the convection currents in the mantle? The energy of that convection current pushes up, pushes the plates this way. How fast are the plates moving? 20 millimeters per year. That's 2 centimeters per year. That's about this much. That's still significant, you know. Where's that plate going to go? Well, it's going to go and it's going to sink under a continental plate, you see. It's going to sink, and then it might cause a volcano to go, okay? This motion is very important for life. Nowadays, astronomers believe without this activity, you cannot have life because you causes volcano spews out oxygen and other materials that we need. You know what I mean? So this is a very active planet. You need this activity. Oh, okay. The other way that we know that this is happening is we can take the mid-Atlantic ridge and do carbon dating along its surface. We do carbon dating. We find out that the rock right where the mid-Atlantic ridge is the younger rock. As you do the carbon dating on these rocks, they're older. Okay? 0, age in millions. 5 million years old, 10 million years old, 5 million years, 10 million years old. So what does that prove? The older rock went, newer rock came. Then that one went, newer rock came, you see? So very active, you see that? So this is proven by the carbon dating. What other kind of boundary is there? Convergent boundary. Convergent boundary is very, very important. That's where two plates move into each other. You see, they're not coming apart, they're coming together. Now, if they come together, what kinds of things can happen? Watch my fingers, guys. If they're coming together, they can either push each other up, then you form what? Mountains, right? Push each other up, mountain. Push each other down, you form what? Trench. Opposite of a mountain. What's a trench? It's in the middle of the ocean, the deepest part of the ocean. What is the deepest trench? Mariana Trench in the Pacific Ocean right here. You see here the trench? Japan Trench. These are the trenches in the ocean. You see how the plates are coming together? Going like this. They're both sinking. That's the deepest part of the ocean. Okay? If we try to send a submarine there, it probably can't make it all the way down. You know, it will be crushed by the pressure of the ocean. The other opposite is when it's going up. So what's an example of a good ocean trench? Right here, the Mariana Trench is along the, this part, the Japan. What's a good case of building a mountain? Coming together, going up. What mountains are they? Starts with H. Himalayan mountains, right? Northern part of India, China, they push each other up. They form the biggest mountain range in the world, okay? What's another one? Subduction zone. That means one plate goes, they're coming together, one plate goes under that one, subducts. The other one might come up, see, like this. Okay? So you could have one subducting on the other. You could have both of them push each other up, or you could have trench, you see, pushing each other down. So without this activity, we wouldn't have any mountains and cool stuff like this, right? What's the third kind? Transform boundary. Well, that's the one good example where we live, LA. The two boundaries passing each other, passing by each other. Okay? So this slide shows you a little bit of this. You see, divergent boundary, going this way, Mid-Atlantic Ridge. This one, convergent boundary, coming down. This is a subduction zone. Subduction zone type of convergent boundary. This plate comes, goes under, subducts. This one, that's San Andreas Fault, okay? So if you look at the San Andreas Fault, you see here? This is the California, the edge of California. This is Los Angeles. The San Andreas Fault comes here, goes like that. You see, cuts through California. This is the location of the primary earthquakes. 1952, 2004, 1983, 1906, the famous San Francisco earthquake. 1994, the Northridge earthquake. Do you notice they're all close to that? As this is sliding, that's what's going to happen. You're bound to have a big earthquake one day, you see. Eventually what's going to happen, if this is California, I'm just going to draw a rough picture of California. This side of California will split. And this side of California will come down, this side of California will go up, and this side will become an island. It will completely split from that side. And of course, there's Baja California down here, right? So it will come, it will break apart, and it'll become an island. So if you have property over here, property value is going to go up. So buy homes. Buy homes on this side of the plate. Okay, and the motion of plates explains all kinds of phenomenon, such as volcanoes, earthquakes, and island chains. In fact, some astronomers believe that only planets with continental drift can sustain life. With that, Wednesday, we'll start with atmosphere.